It's now recording.
You didn't do your rough draft.
See that?
I didn't do it either.
Tony. See? That's Amy Doe speaking. All right, here we go. For the function y equals x squared plus e to the negative x, fine, a and b, here we go. A simple, very basic function as a right end behavior model. So, what would you do? What on earth is a right end behavior model theorem? What did you write down on your notes? Right end behavior model. In your notes, what did it say? The limit of f of x divided by g of x equals 1 as x. Beautiful, okay? Now remember, the g of x is the right end behavior model. It's the g of x. So really, I'm really just looking for g of x equal to something, right guys? Okay? All right, here we go. You got f of x, which is in this case y equals x squared plus e to the negative x. What must g of x be so that way when we take the limit as x approaches something ginormous, like 1,000, like 100,000, like 1,000,000, okay? The limit of your original function divided by g of x is equivalent to 1 or near 1. What would you say? You said x squared? Why x squared? What do you mean by that matters? You're on the right track.
Because as x is approaching to infinity, the other number that's being added to it doesn't become as the x value next to it.
Okay, good job. Would you agree that x approaches like infinity? I'm going to pick like 1,000 because that's easier to understand. Okay. Out of these two terms, which one of those is not significant? Which one of it is so small that it doesn't really matter? E to the negative x, right? Because it's 1 over e to the positive x. E to the positive x, x is 1,000. That's a big number. But 1 over a big number is very, very small. So out of those two, this is insignificant. So the only one that's left is x squared. And you are right. G of x equals x squared is your right end behavior model. Similarly, for the left end behavior model, what's the theorem? Limit? That's right. Okay. So again, we're looking for what? F of x or g of x? G of x, right? Okay. Equal to something. Is it the same? Is it x squared still? Yes or no? Okay, so this one, we're looking for x approaches positive 1,000 or negative 1,000? Negative 1,000, okay. All right, over what? So that way. Okay, now you have to think about which one's insignificant. If I'm approaching negative 1,000, negative 100,000, negative million, which one's going to be more dominant then, if you don't want to think insignificant? Which one can I eliminate if I'm approaching negative 1,000,000? Which one will grow faster? Would you agree exponential is always going to grow exponentially faster? Right? So if I put in 1,000, negative 1,000 squared, that's going to be a positive number. But let me tell you right now, that's going to be a lot smaller than e to the negative 1,000. That's really e to the positive 1,000. E to the positive 1,000, that will grow a lot quicker than negative 1,000 quantity squared. So out of those two, the e to the negative 1,000, because you're approaching negative infinity, is more dominant. So that's your left end behavior model. So in short, you're just looking for which one is more dominant, which one will grow faster. If that's the one that grows faster, then the other one is not as significant. Any question on 7? 8. Here we go. Same thing, except I'm giving you something else. Here we go. Find the right end behavior model for y equals x squared plus sine of x. That means I'm looking for g of x again. Okay, so right end behavior model is when x approaches what? Infinity. Out of these two, what do you think? X squared? How come? Why x squared? Why not sine of x? Sine of x, guys, the max is what? 1. And the lowest is? Yeah, so max is 1. And lowest, min, is -1. So definitely it's not significant. It's not as significant as x squared. So your right end behavior model is just simply g of x equals x squared. How about left? What would you think? What is it? It's still x squared, right? Because sine of x, the high is just 1 and low is -1. It's not as significant as -1,000 quantity squared. So this one, they both happen to be exactly the same. As you can see, 7 and 8, are they always the same? No, it depends on what function is given, right? Number 9. What kind of function is this? Piecewise. How many pieces? 2. Now, when in doubt, you can always do what? Plug a number, graph it out. When in doubt, graph it out, and then you can see where it's approaching. But we're going to practice without graphing it out. Ready? For the function f of x, you have 2 pieces. X minus 2 divided by x minus 1. X is less than or equal to 0. And then the second piece, 1 over x squared. X is greater than 0. You're asked to find 4 limits. So the first one is the limit as x approaches -infinity. So this is as x approaches -infinity. Out of those 2 pieces, which one is applicable for this question?
First one.
The first one, because the first one, look at the restriction, right? It's the only one that's approaching -infinity. So I'm going to use that, x minus 2 all over x minus 1. Okay, let's find the answer. What's the limit? Remember, when you are having an x approaching positive and negative infinity, what are you looking for? Just the significant terms, right? What's the significant term on the top?
X.
What's the significant on the bottom? So 1, you're right. Okay. Isn't that also the horizontal asymptote if I ask for it? Okay, B. Similarly, find the limit as x approaches infinity. Out of those 2 pieces, which one is applicable? The second, because x is greater than 0. So, same thing. What would you say the limit is? 1 divided by something ginormous is approaching 0. Okay. So, is that another asymptote if I ask for it? C. Which one is applicable? Find the limit as x approaches 0 coming from the right. Which one has the right piece? Yeah, right? Because this is greater than 0. I mean, stuff is on the right-hand side. If I'm coming from the right, would you be coming this side? So that means this one over 1. Okay. Now what? Can I substitute? No. So that's not going to work. What are you going to do here if I can't substitute? Huh? I can't simplify or reduce, right? Do something close. Like what? Yeah. 1 over 0.00001. What's happening? Big number. How big? Infinity. You're right. So this one is heading towards infinity. Okay. So that looks like you're going to have some sort of a discontinuity, right? How about the right side? Looks like that's 0. Limit as x approaches 0 from the left. Which piece? The first one. It's, oops, x minus 2 divided by x minus 1. All right. Can I substitute?
Yeah.
Sure. Final answer. 2. See? All right. Theorems. You're going to have 3 quick theorems for this one. One of it you guys already saw. Okay. So it should be theorem number 1. If I said find the limit of sine of x over x as x approaches either positive infinity or negative infinity, it doesn't really matter. What do you guys remember the answer was? Not 1, because that's x approaches 0. What's the answer? 0. Remember, sine of x, the most it can be is what? 1. The lowest it can be is -1. So when you have positive -1 and divide by 1,000,000, it gets pretty tiny, right? It is 0. Theorem number 2. The limit of f of x as x approaches positive infinity sometimes is pretty difficult to find. So when that is difficult to find, you can find the limit of f of 1 over x as x approaches 0 coming from the right. Those two are equivalent. Okay. And then the last one, it's the same thing as 2, except it's approaching negative infinity. Negative infinity, sometimes it is more difficult to find. So if it is, you can do limit of f of 1 over x as x approaches, guess what? 0 from the negative side, from the left side. We're going to apply that right now in example 10. Example 10, for the function f of x times sine of 1 over x, okay? I want you to find the limit as x approaches positive infinity and negative infinity. So x approaches positive infinity of f of x, and over here, find the limit as x approaches negative infinity of f of x. So your f of x is x times sine of 1 over x. Okay, let's check it out. What would you do? How would you do this? Can I substitute? Can I substitute? So sometimes when it's confusing, we're going to use this theorem. Ready? I don't like, what if I can't figure it out right now, can I go in and do this first? Find f of 1 over x, like that. Yes or no? What do you do, by the way, when I say find f of 1 over x? What is f of 1 over x? What does that even mean? Find f of 2. What do you do? Plug 2 in for x. Find f of 1 over x. Plug in 1 over x for x. That's all that is. Okay. So I'm going to take this function. I'm going to rewrite it as f of 1 over x. So this is now 1 over x times sine over 1 divided by 1 over x. So what does that make? That's right. It's just x. Which is, would you agree that's really sine of x over x? True or false? Yes, no, maybe. Based on our theorem, the limit as x approaches infinity is the same as x approaches 0 coming from the right of f of 1 over x. True or false? I already have f of 1 over x. What is f of 1 over x? Sine of x over x. As x approaches what? 0 from the right. Don't I know that right away? What's that answer?
1.
It is 1. Right? That is slightly easier to find than the original. Similarly to the right, instead of finding x approaches negative infinity, I'm going to use my theorem. X approaches 0 coming from the left of f of what? 1 over x. So that means the limit as x approaches 0 coming from the left of sine x over x. What is that answer? Also 1. So, there you go. Uh-huh.
How is 1 over x divided by 1 over x?
1 over x. Where are you at?
On the first part, when we plugged in
Right here?
f of 1 over x, and we plugged in for x in the previous equation or function, how was that x?
So, like, are you talking about, like, when I did this? 1 over x?
Yeah.
Okay, so would you agree that this is x?
I know that.
Okay, so this is 1 over x like that?
Oh, I'm stupid.
No, but are you...
I got it.
Okay, no, I just want to make sure if I wrote something too quick. You guys okay with those? Okay. All right. And then what happened is the sine of 1 divided by 1 over x like that. All right, that's an egg roll.